Okay, good afternoon, everyone. Let's wait for 5 or 10 minutes. Then we'll start the class. Okay, let's wait for okay. I'm sharing screen. You please check is it visible or not. I'm audible to everyone. Can anyone tell me? Okay, okay. First, okay. I'm giving one question. We'll solve it. Do you have any question on the previous lecture? I already discussed in the class. Okay, I'll calculate. Okay, I'm first writing the question, then read. Efficiency levels of a diatomic molecule separated by okay, and WEXC is provided 14 centimeter inverse. Now the question is we have to calculate the first turnover over 2 in centimeter inverse. Okay, now first you see that they gave the enharmonicity constant xc value. So first we will think that this they're talking about some enharmonic molecule, okay, diatomic molecule. So what is the energy expression for a diatomic enharmonic molecule? Omega xc centimeter inverse, okay. Now they told that v equals to 1, 0 to v equals to 1. So 1 to 0. What will be the putting v equals to 1 here because this is the energy gap. Okay, daily. First, okay, I'm writing it here. First means 1 minus h0 omega e minus 1 plus square omega e x minus e0 what will be v equals to 0. Okay, now p by 2 minus this thing I am taking in one side. This is 9 by 4. 3 by 4. 3 by 2 means 9 by 4 xc omega e bar minus 1 by 4 plus minus plus. They provided the del E that the energy levels, you read the question, the vibration energy levels of a diatom will separated by atom. Separated by atom means that this is the energy gap of v equals to 1 to and v equals to 0. So first, for the thing, whenever they are telling about energy gap, it means that that we have to first we have to calculate the energy of equals to 1 and then we have to minus it from the v equals to 0 energy level. That's what we are doing. Okay, now what will be the value? 3 by 2 minus half means 2 by 2 means 1 means omega e bar minus this one omega 1 3 by 2 1. This one will be 9 by 4 minus 1 by 4. Okay, 8 omega e bar minus 2 omega e bar xa. This is the energy. Okay, del E. Del E equals to what they gave. What the number? 2143. Okay. So for the thing omega e bar minus 2 omega e bar xc, this is the value 2143 centimeter inverse. Always write the unit. Now we have to calculate the okay. Here I need to ask one question. Here they told to calculate the first overturn and the second question is calculate the value of omega e first. Okay. For to calculate the first overturn we need to know the omega e, but here just for simplicity I am giving these two questions. First question, calculation of omega e bar. Okay, omega e bar equals to 2143 plus 2 omega e bar x centimeter inverse. So what is the value of omega e bar x bar? They 14 centimeter inverse. 15 means all are in centimeter inverse. Okay, what will be the value? 2143 plus 28 2171 centimeter inverse. Did you get this? Okay. Okay, I'm moving to the next part. Next part was calculate the first overturn. Okay. Then we have to know the what is the first overtone. This is the energy gap in centimeter inverse. This is important. Between E2 minus E0. This is the first overtone. And then what will be the value? V equals to 2 means 2 plus half omega E bar minus 2 plus. I am just putting the value of the energy. Here I am putting, okay. Let me see. Here V equals to, now I am putting V equals to 2 minus of omega E. So this 4 5 by 2 minus half omega E bar minus 25 plus 1 by 4 and means 6 omega E bar xc. Okay, now I will just put the values here. Omega E bar, what we calculated, 2171 minus 6 into this, they already provided 14, all are in centimeter inverse. What will be the value? 4258 centimeter inverse. I think this is the value. Okay. This is the first overtone of the transform transition of the diatomic anharmonic molecule. So for the thing, this was a question. Now we solved this, we solved, and this we solved. Now I'm moving to the next question. First I'm writing the question. Okay. The molar extension coefficient they told of tyrosine and tryptophan. Okay, let me write it otherwise. Say tryptophan and tyrosine 20 nanometer are and 1280 centimeter. Sorry. Mole inverse, centimeter inverse. 1 minute, okay. Sorry. Yeah. Okay, this is the question, and they told the peptide chain of the coronavirus molecular weight. They gave molecular weight of the 11 tryptophan and 58, 54 tyrosine. Now we have to calculate the absorption of now they all also provided the absorption at eto and path length they provided 1 centimeter. Okay. And now I have to calculate path length, first the molarity of the protein solution, and another what thing, oh sorry, I think this is the concentration they provided. This is the concentration they provided like that, and we have to calculate the absorption. Absorption means first for the things we have to, they already provided. I will write here epsilon of tryptophan 5690 tyrosine 1280. And they also provided the concentration, they also provide the molecular weight also. Molecular weight they provided, okay, let me write it here. Molecular weight they provided like that. Okay, now we have to calculate the, okay, now they have to calculate the absorption. Okay, for the absorption, to calculate what the things we have to know, epsilon Cl, epsilon molar extension coefficient of the solution, concentration of the solution, path length of the solution. Among them, what we don't know, first we don't know the epsilon of the solution, as we only know that the epsilon of the 2 amino acids. Okay, now we calculate the absorption. So absorption of the solution, absorption of the protein, which consists of 11 tryptophan and 54 tyrosine. Okay, number of tryptophan 11, number of tyrosine 54. Okay, now epsilon 1 plus epsilon 2, because it consists of two things, tryptophan and tyrosine. So what will be the value of here epsilon 1 they already provided. This is the epsilon 1, this is the epsilon 2, but it consists of 11 tryptophan, so we have to multiply the I think okay, I think everything is fine, but where we are here, so it consists of 11 tyrosine molecules. And what is the value of tyrosine? Epsilon 2, epsilon 1, what was there? Epsilon means the molar extension coefficient of tryptophan, this one 5690 plus 54 tyrosine molecules are there, and what is the value of molar extension coefficient? 1280. Okay. Sorry, centimeter. Sorry. So now what is the value of it? 131710. You please do it, otherwise it's just epsilon 1 plus epsilon 2, because it consists of two proteins, tryptophan and tyrosine, and there are 11 number of tryptophan, and it consists of 54 number of tyrosine. So I just multiply the molar extension coefficient with the number of proteins. Okay, now this is a molar extension coefficient of the protein. Now what the things we got it. Now the concentration, what they provided, 0.32 milligram ml inverse. So 0.32 10 to the power minus 3 gram divided by 10 to the minus 3 liter means 0.32 gram per liter. Okay, now what we have to know, the concentrations will be in molarity. So molarity, it is in gram, no? Okay, 0.32 gram per liter. For molar we have to transform what the things, 0.32 divided by gram by what is the molarity. We have to transfer it, we have to divide it with the molecular weight, then we will get the mole. Liter inverse, or it will be mole per liter, means mole per liter, means this will be 0.32, this will be molar. What will be the value of mass? Molecular weight, they provided, what was the value? Molecular weight they gave, this is the molecular weight. Okay, Dalton, they just gave it in Dalton, 1.178 Dalton. Dalton we have to transfer in the gram, otherwise this, okay, I should write the unit here, no? 141,178 divided by, gram per this one, gram per mole. Okay, so okay, I should write the unit here, otherwise confusing. 0.32 divided by 141,178, this was gram per liter, no? This one will be gram per mole. 0.32 41178. So per mole, mole per, right, or gram per mole, okay, mole inverse. So gram per mole, this is Dalton equals to gram per mole, so I am just transferring it into mole. Okay, 0.321411 mole per liter. So now what will be the value? Mole per liter means molar, means what is 0.32 divided by 41178, means this is the molar, means 2.2. You calculate this, then you will get into minus 6 molar. Into minus 6 means 2.266 into in micromolar. 1 molar equals to 0 minus 6 molar. 1 micromolar equals to 10 minus 6 molar. So this is the concentration. What the things we get? First we calculated the this one we calculated, and this thing we all again calculated. Now just we have to put the values here equal to epsilon CL. Epsilon, what we get? This one, no? So I'm just putting it here, 131710 into here the concentration. Sorry, its unit was mole inverse, centimeter inverse, and here the unit of concentration 2.266 molar. Okay, path length 1 centimeter they gave. So what the things will this thing, and this thing. Now the answer will be 131710 2.2266 into 10 to the power minus 6. This will be your answer, 1298. You please calculate and let me know whether I am also doing right or wrong. Otherwise you can't understand it. Or if you have any doubt, you can ask me here. Okay. Now I will moving to the next question. Let me check once. Okay. I have to calculate the relative population. Rotational spectroscopy said already. These things are already discussed. So my here the question is, we have to calculate the relative population of n equals to 2 level, and okay, I'm providing the data. They gave b equals to 2 centimeter. I am giving the data, then we'll solve. They only give only this value. Okay, we have to calculate relative population. Relative population n equals to 1 with respect to n equals to 0. Now for relative population, what the things we have to know? N2 minus divided by n0. This is according to Boltzmann distribution formula. You please go through the lectures, then you can easily understand what we are explaining here. E1 by kt minus E0 by kt. First, for rotational spectroscopy, what is the value of energy that we have to know first. This is the, you all know, this is the B. Okay, now I will just okay, here one thing you have to know first. Okay, how to tell? Okay, this thing, if it is centimeter inverse, then this thing has to be centimeter inverse, otherwise they will not deduct each other, means the centimeter inverse will not be cancelled out. But it's not possible here if you want to take the exponential of something. So we have to transfer it to this unit, means kt unit. What is the value of kt? What we get? R by Na into T. R unit is 18.314 joule Kelvin inverse mole inverse. This is the 6.023 into 10 to the power 20 mole inverse. Okay. Temperature they also provided. Yeah, temperature they provided. Na temperature they provided 300 Kelvin. 300 Kelvin. But the things are okay. What is the okay? This will be the unit. What will be the unit? Joule. Only joule. Okay, so this unit has to be in the joule, otherwise joule will not be cancelled out. So how to transfer this thing in joule? I'm writing it here. So if we multiply, sir already told another one equation. If you can remember, then that it's fine. I usually remember this equation only, and then I transfer it to there. You can also remember that equation also. Means as the b is given in the centimeter inverse, here b is provided in centimeter inverse, no? So I am just writing this formula which is in centimeter inverse, but we have to transfer the e in the joule, otherwise these two things will not cancel out. So what the things we have to do? So how to calculate this thing? We have to multiply. Okay, I will first, let me write. Okay, how I just only discuss how the units are getting balanced. Okay, but the h just only first we'll understand the unit, then we'll calculate. Okay, joule second, sorry, joule second, and see meter per second. Okay, then you see these two things cancel. You can transfer it to centimeter, then these two will cancel. Okay, then it will be in the joule. So now I am putting the value of here. I will put this e value. Then this is the j, the quantum number, rotational quantum number, and this is the unit. Okay, joule. So n1 minus n0. First we'll make the unit clear. Okay, energy expression will put this equation, not this. I think you can understand how I will transfer it to centimeter inverse to joule to cancel these two units. Now I will put the values here. Okay, first n equals n1 by n0, n1 by kt minus e0 by kt. E0 BHC, j will be 0, 0 plus 1. I am putting here the value of 0, here j equals to 0. So what will be the value of 0? E0 when j equals to 1, E1 will be 2BHC. So what will be the here the value? Minus E1, this one will be the 0, this one will be the 0. Exponential 0 means 1. 1 by then E1 means B 2BHC by kt. Now we will now 1 minute. N1 minus N2, sorry, N0, what is the value? Minus 2BHC by kt. Now we will put the values. Okay, carefully. 2 centimeter inverse. HC 6.626 into 10 to the minus 34 joule second. H C 3 into 10 to the 10 centimeter second inverse. Now the lower value k equals to r by na. Here I saw r by na 8 point. K equals to r by na means you calculate it 8.314 joule Kelvin inverse mole inverse into 6.023 into 10 to the power 23 mole inverse. To calculate this thing 8.314 n Avogadro number joule Kelvin inverse. So 8.314 divided by Na into T. Temperature, what is the value? 300 Kelvin. Here, what is the value of, what is the unit of this? This is the unit of this, okay? I'm writing it here. Now we'll separate the values and the units. Okay, 8.314 by Na. This is the Avogadro number, okay? Na into 300. Unit what will be? Centimeter inverse, centimeter inverse. Okay, second inverse and second inverse also. So above is joule, below is joule. Only this thing. There is no other unit here. So we have to calculate this the value, and finally what you will get. You please do it. 0.0. I am just writing the value, but you just put it in calculator. You will get it. But the main thing, you have to understand the what is about the concepts and the units. Unit I always give the more attention. All units and the concept you have to remember. Okay, means not remember, means understand. Sorry, 9. So n1 minus n0, 0.98. So what we are getting, this is close to 1. You are getting now, this is 0.9 is close to 1. So what conclusion we can, conclusion also I am writing. If someone watch this video, then they can also understand. That's why I am writing. So what the conclusion we can get from n equals to n and n0 are almost same. Means at 300 Kelvin, two energy levels are equally populated. This is the population. So two energy levels are equally populated. N equals to 1 and n equals to 2. So this has a lot of meaning. Now I am not going in details, but if you remember this thing, means if someone study in chemistry in future, then these things it's have a lot of importance. You will read all these things later in a better extent, but for time being I am just saying that this is very important. You have to, means if you there are a lot of other actually energy levels are there, then you can also understand that is this temperature, these energy levels are populated. So this temperature, which vibration levels are will be populated, or electronic contribution will be there or not. Means these things are very much important. At first, for this level, I think you have to know how to calculate these things, and when you will go in the further study, then you will, means better understanding. I think no page is left here. Okay, let me add more pages. Okay, I have another question, but I think it's took a long time. Okay, let me solve this. Or you people having any question? Okay, let me solve this. Okay, I'll solve it. Okay, what is the, they gave the okay, for rotational frequency they gave the 0 to 1, transition 235 centimeter inverse, and we have to calculate. This is the I value and mu value we have to calculate. So for to solve this problem, we have to first know what is the thing. They gave the energy gap, okay, energy of absorption energy in centimeter inverse. This will be determined by the means a molecule is getting energies to higher energy level. How much energy it needs, it depends on the energy gap between the two energy levels. So here they told that whenever transition happens from 0 to 1 energy level, that much energy it consumes. So if we so what will be the this is for rotational, okay, rotational transition. So first we have to know, for knowing anything means to understand that how much energy a molecule needs to transfer or to give transition from J equals to 0 to J equals to 1. We have to first know the energy equation. What will be the energy equation? This is the rotational quantum number 0 equal to 0, 1, 2. Okay. This you can call as a B, J plus 1 centimeter. Now we have to calculate EJ, means J1 minus E0. 0, here you put the J equals to 0, it will be 0, 1, so 2B centimeter. This, okay, they provided. What they provided then? 3.84235 centimeter inverse. Now they told to calculate, here you put another thing, calculate the value of B. B, what will be the value? 2.3, sorry, this value divided by 2 centimeter inverse. So value of B will be 1.92118 centimeter inverse. First question solved. So then they told to calculate the value of I. Now what will be the value of B? I am writing this thing again and again. Okay, I h by 8 pi square c into this value. Okay, now again this units, I am putting the value of h, joule second, 8 pi square, it's in centimeters, so 10 over 10 centimeter, or centimeter per second, into 118 centimeter inverse. So these things will deduct each other. Okay, now what will be the value of I? Or 8 pi square. Now the unit thing, yeah. Joule means kg meter square second to the power minus 2 square into joule. This is the joule, and this value was joule second, so joule into second. Down part is second inverse. Down part is only second inverse is left. So these two multiply gives second inverse, and there is second inverse. So you please calculate the value of it. I already calculated it from before. So what will be the value? 14.569 47 kg meters. This is the another question. Now the ultimate thing means mu. Many people do mistake here, so I will show means where usually people do the mistake. Mu r square. Everyone knows this, but where the mistake happens, okay, mu people usually actually people do the mistake in calculation of mu. Mu is m1 m2 by m1 plus m2. It is also everyone known, but what the value of m you will put, this usually people do mistake here. This is not the means just like carbon, okay, 12, everyone knows it, but you can put it here, but it will not be means for the thing means this will be in the gram only, means okay, m1 m2 na, m equals to m by na, okay. So this value you have to write here, m1 by na. Na is the Avogadro number, m2 by na. Per mole you have to calculate. Per mole you have to calculate. Okay, you please don't put this thing here. Then you will do the mistake. This is very important thing. I usually do many times mistake here. So I am just highlighting it. You have to write the m by na, means m1 m2 by m1 plus m2 1 by na. Okay. Now other things are okay. Sorry, I think I have. Let me add more pages. Okay, where are we? Okay, mu calculation. No, okay, mu value will be okay. Here, this they told this is the carbon monoxide molecule. So, what carbon 10 to the minus 3 kg kg. I'm transferring it in kg. Okay, this one will be. Oh, sorry. Here, kg mole inverse. So here will be kg per mole. Another thing is there, Avogadro number 1 by Na. So 12 into 16 into 10 to the power minus 6, 12 plus 16 into 10 to the power minus 3. These two, one will be cancelled out. Na 6.023 into 10 to 6.0 to 10 to the power 23 mole inverse. Okay. Then sorry, this one, this value will be I also did this and I got 10 to the power minus 26 kg. You also do it because this is cancelled, only kg is left. You please do it yourself and you please do it, then you can understand means better. Okay, now what will be the value of mu r square? What will sorry mu r square, what we got, I value 14.569. we already calculated this. Mu also we calculated r square. Now I will put the values only. kg meter square. Mu value, what is the value? 1.138 10 to the power minus 26 kg. Units always tell the right thing. You can also get it from here. 138 into 10 to the minus 26. You see here meter square is coming. Sorry. What will be the value? 12.8 meter. I got it 1.13 10 to the minus 10 meter. 1.13 next. Here this is the value of R. Meter, okay? This is the meter. Root over it you are doing means it will give the meter. So what the things they are mu so R here R one thing. R also calculated. I also mu also all the things we calculated. That's all for from my side for today. Okay. Okay, let's end the class today. We'll meet in the next week. If you have any question, then keep posting. Okay, that's all from my side. If you have any question, you can ask me here. Okay, we'll meet in next Saturday. Thank you.